equivalent equations and additive property of equality, all right? So equivalent equations are equations that have the same answers, okay? Two equations are equivalent if every solution of either one of the equations is also a solution to the other equation. Are these equivalent equations?
Yes.
Yes, because what's the answer to this equation? X equals what? And what's the answer to this equation?
X equals 3.
Yes. And so every solution, there's only one in this problem, there's one solution, okay, is also a solution. It's an answer for both, all right? If it's an answer for both, they are equivalent equations. All right, don't write this down. The additive property of equality. Basically, you are allowed to add anything to both sides of the equation, and the equation stays the same, or subtract. For example, if I have A plus C equals B plus C, I could just subtract these C's from both sides, and that means A equals B. Okay, same thing over here, minus C, A equals B. All right, or I could just be like, I'm going to add 9 to both sides, and that's totally cool. You could do that, all right? A plus 9 equals B plus 9. It doesn't change the value of the equation, so whatever you add to one side, make sure you add to the other side. That is legal math. Now we're going to solve really easy equations today, all right? So I know you guys already know how to do this, but this is what I want to see today. All right, so you're going to write it down, and then I want you to show me the step that you take to get x by itself. All right, so Maddie, what do we do to get x by itself? Yeah, so just show me that, okay? And then the answer is x equals 12. Now, after today, you can just be like, that's the answer, and that's all you have to do. Just on today's homework, I want you to show the check, because actually some people really get confused on how to check their answer, all right? How do we check that this is right? You take this lovely 12 and you plug it back in for x. So we do 12 plus 5 equals 17. And then I do need to see that you add those together to get 17 equals 17. And so yay, we did the problem right, and the answer is 12. Okay? Yes. No, you don't. All right, k minus 27 equals negative 38. Bishnu, what do we do to solve this equation and get k by itself?
You would add 27.
Yes. All right, we're going to add, 27 to both sides. So these cancel out. We get the k by itself. And then here I have negative 38 plus 27, which is negative 11. All right, and then just for today, you are going to show that you checked this. So you plug in negative 11 for k, and you rewrite the equation. And then we get negative 38 equals negative 38, which is true, so we did it right. All right, add in a little bit of fractions, okay? Make it slightly harder. Emily, what's the next step in this problem to get the x by itself? Exactly. We just add 1/2 to both sides. Okay, in order to add fractions, we have to do what, Josh? What do I have to do to add these together? Exactly. So I got to make this out of 8. So I need to multiply by 4 over 4. All right. So I'm really adding 4/8. That's the same as 1/2. So 3/8 plus 4/8. I ran out of room. Let me scoot this down. Okay. 3/8 plus 4/8 is 7/8. Okay. Over here, these cross out, plus and minus. We get the x equals 7/8. All right. And then we would check it by doing 7/8 minus 1/2 equals 3/8. All right, this is really 4/8, common denominators, so I get 3/8 equals 3/8, okay? Last one, write this one down if you took a little breather because you were like, I already know how to do this. Go ahead and write this one down because this one's like, it's kind of hard, okay? It's a little tricky. All right, so again, I like to do this line. You don't have to do that, all right? Just splits it in halvesies. Whatever you do to one side, you do the other side, right? That's your equal sign. All right, so I have 4 1/7. I need to like get rid of it. Integral, how do I get rid of this right here and get the d by itself? Yep. Minus 4 and 1/7. So those cross out. We have D equals. And then you're like, what is happening right here? All right. So first of all, I have a negative number and a positive number. So we are going to subtract them from each other, right? Is my answer going to be positive or negative? Yeah, the negative is bigger, okay? So everybody should be agreeing that your answer is negative because the negative is bigger. Does it matter the order I subtract?
No.
So I would actually do the 4 and 1/7 minus the 3 and 1/6, even though I know my answer is negative, okay? Because it just makes more sense to do. It's just easier to subtract this way, all right? Now I need common denominators. What do both 7 and 6 go into? 42. So I'm going to multiply this by 6 over 6. All right. And 6 goes into 42. I'm going to multiply this by 7 over 7. All right. I do need to borrow from the 4. All right. To make that a 3, I'm going to have to add 42 over 42 right there. Okay. Add that whole piece. So now I have 3 minus 3. Okay. The whole numbers cancel each other out. Right here, I have 6 plus 42. That would be 48 over 42 minus 7 over 42. So we get 41 over 42, but my answer is negative because originally the one that was bigger was negative. So the negatives won the war, okay? All right, you guys, let's try some whiteboards.